So in today's class, we will get started with complex numbers and De Moivre's theorem. EAMCET level, okay? So take the first question. If root 5 minus I root 15 equals to R into cos theta plus I sin theta, where minus pi less than theta less than pi, then R square secant theta plus 3 cosecant square theta equals to dash. Option A 40, option B 60, option C 120, option D 180. So let's see how do we solve it. So what is given to us? Root 5 minus I root 15 equals to R into cos theta plus I sin theta. So R is equal to, now if you compare both real and imaginary parts, you will get R cos theta equals to root 5 and R sin theta equals to minus root 15. Now we do squaring and adding. So we will get R square is equal to 5 plus 15. That is equal to 20. So what is R? R is root 20. Root 20 can be written as 2 root 5. And always remember, how do you get the theta value? Theta is tan inverse of y by x, where y is imaginary part and x is real part. So that is equal to tan inverse of minus root 15 by root 5. Now root 15 we can write it as root 5 into root 3 by root 5. So root 5 cancel. That is tan inverse of minus root 3. So theta is tan inverse of minus root 3. So when is tan theta minus root 3? It is at minus 60 degrees. Minus 60 we can write minus tan pi by 3. So tan and tan inverse get cancelled. That is minus pi by 3. So you got theta value. After getting the theta value, we need to substitute the theta in the given expression. So after finding theta value, let us substitute it in the given expression. R square into secant theta plus 3 cosecant square theta equals to R is 2 root 5. So R square value also we got over here, that is 20. So R square is 20 and this is secant of minus pi by 3 plus 3 into cosecant square of minus pi by 3. So 20 into secant of minus pi by 3 is secant pi by 3 plus 3 cosecant square pi by 3. Now what is secant 60? Cos 60 is 1 by 2. So secant 60 is 2. And plus 3 into cosecant 6. See, sin 60 is root 3 by 2. So cosecant 60 is 2 by root 3. And cosecant square 60 is 4 by 3. 3 get cancelled. That is 20 into 6, which is equal to 120. Option C. Now take the second question. The point P denotes the complex number z is equal to x plus iy in the Argand plane. If 2z minus I by z minus 2 is a purely real number, then we need to find out the equation of locus of P. 4 options are given to us. So now let us see how do we solve it. So we have z is equal to x plus iy. So therefore 2z minus I by z minus 2, let us find out. In the place of z we will put x plus iy. So 2 into x plus iy minus I by x plus iy minus 2. Now from here we will separate real and imaginary parts. So if you open the brackets, you will get 2x plus 2iy minus I by x minus 2 plus iy. Now here 2x plus I, if you take common from these two terms, we will get 2y minus 1 by, in the denominator also we are separating real and imaginary parts. Now we will rationalize the denominator. So in the denominator, if you have plus, multiply and divide with minus. So multiplying with x minus 2 minus iy by x minus 2 minus iy. So that is equal to, now if we multiply both the terms, so you will get 2x into, see first 2x we are multiplying with both the terms. So 2x into x minus 2 minus 2ixy. Then I into 2y minus 1 we are multiplying it with x minus 2 minus I square y into 2y minus 1. So how did we multiply? This into this into this, then this into this into this. Like this I multiplied. Denominator is a plus b into a minus b. So we can take a square minus b square. Now we need to solve this all. So 2x into x, 2x into 2. Like this you have to solve it. So after solving, you will get 2x square minus 4x plus 2y square minus y. This is real part. So I am dividing it by x minus 2 whole square plus y square. Then x minus 2 into 2y minus 1 minus 2xy. After simplifying, I am separating real and imaginary parts. So we get this. But what is given in the question? Since 2z minus I by z minus 2, it's purely real given, which means its imaginary part is 0. So the imaginary part is x minus 2 into 2y minus 1 minus 2xy by x minus 2 whole square plus y square is equal to 0. So if you cross multiply, you will get 2xy minus x minus 4y plus 2 minus 2xy is equal to 0. If you take 2xy cancel, and if you take minus common, you will get x plus 4y is equal to 2. And because in the denominator you have x minus 2 whole square plus y square. So x value is 2 and y value is 0. So values of x and y should not be equal to 2 and 0, because otherwise if denominator becomes 0, the whole term will be undefined. So the condition is x is not equal to 2 and y is not equal to 0. So which option satisfies this? It is B. Option B. Now take the next question. X and y are two complex numbers such that mod x is equal to mod y equals to 1. If argument of x is equal to 2 alpha, argument of y is equal to 3 beta, and alpha plus beta equals to pi by 36, then we need to find the value of x power 6 y power 4 plus 1 by x power 6 y power 4. So first, what is given to us? Given x and y are two complex numbers with mod x equals to mod y equals to 1 and x is equal to e power I 2 alpha. And y is equal to, because argument x is 2 alpha, so we can write x as e power I into 2 alpha. And because argument y is equal to 3 beta, we can write y as e power I into 3 beta. where alpha plus beta equals to pi by 36. So now we need to find out x power 6. What is x power 6? E power I into 2 alpha whole power 6. That is equal to e power I into 12 alpha. Now the same way y power 4 is e power I into 3 beta whole power 4. So that is e power I into 12 beta. Now if we find x power 6 y power 4, you will get e power I into 12 alpha into e power I into 12 beta. So a power m into a power n is a power m plus n. So we can add the powers. E power, if I take like I into 12 alpha plus I into 12 beta. So if we take e power I into 12, if we take common, we get alpha plus beta. But in the question, alpha plus beta is given as pi by 36. So that is equal to e power I into 12 into pi by 36. So this is 12 ones are 12 threes are. So that is e power I into pi by 3. This is x power 6 into y power 4 value. So we got x power 6 y power 4 value as e power I into pi by 3. So 1 by x power 6 into y power 4 will be e power minus I into pi by 3. So if we add them, x power 6 y power 4 plus 1 by x power 6 y power 4 is equal to e power I into pi by 3 plus e into minus I into pi by 3. So that is equal to 2 cos pi by 3. This is the formula, like e power x plus e power minus x by 2 or e power ix plus e power minus ix by 2 equals to cos x. Okay, this is the formula. So that is equal to 2 cos pi by 3. Now cos pi by 3 is cos 60. Cos 60 is 1 by 2. 2 to cancel, you get 1. Now take the next question. One of the roots of the equation is, four options are given to us. What is one of the root of this equation? We need to find out. So let's see how do we solve it. So the equation is x power 14 plus x power 9 minus x power 5 minus 1 is 0. So if you like x power 9 minus 1, I am writing over here. And like if we take common terms common, I'll show you how to take terms common. From these two terms, if I'm taking x power 5 common, so we get x power 9 minus 1. And from these two terms, I'm taking 1 common. So we get x power 9 minus 1. So x power 9 minus 1 again common. So x power 9 minus 1 into x power 5 plus 1 equals to 0. Now if we take x power 9 minus 1 is 0. So we get x power 9 is equal to 1 or x is equal to 1 power 1 by 9. Now this is ninth roots of unity. So that is cos 2k pi plus I sin 2k pi. This is the form, general form. Whole power 1 by 9. So that is, now if we apply De Moivre's theorem, we get cos 2k pi by 9 plus I sin 2k pi by 9. Now the same way, if we take x power 5 plus 1 is 1 is 0, then x power 5 is minus 1 and x is minus 1 whole power 1 by 5. Minus 1 we can write cos pi plus I sin pi whole power 1 by 5. So that is cos, what is the general form? 2k pi plus I sine 2k pi plus pi whole power 1 by 5. So that is, if we separate it, we get cos. If we take pi common, 2k plus 1 into pi by 5. We are applying De Moivre's theorem here. Plus I sine 2k plus 1 into pi by 5. So here k takes values from 0 to 8 because you have power 1 by 9 here, and because you have power 1 by 5 here, k takes values from 0 to 4. So one of the root is cos 2 pi by 9 plus I sine 2 pi by 9. So for k is equal to 1. So cos 2 pi by 9 value is, from trigonometry it is root 5 plus 1 by 4, and sine 2 pi by 9 value is root over 10 minus 2 root 5 by 4. So which option is correct? It is option D. Now take the next question. If this is the given expression, then we need to find out 2x plus 4y. So first we will take that expression. So 2 minus I into x plus 1 plus I by 2 plus I plus 1 minus 2I into y plus 1 minus I by 1 plus 2I equals to 1 minus 2I. Now we will rationalize both the terms. Like the first term, we will multiply and divide with 2 minus I. So 2 minus I into x, or else we can do one thing, we can separate all real and imaginary parts. So 2x minus ix plus 1 plus I by 2 plus I plus y minus 2iy plus 1 minus I by 1 plus 2I equals to 1 minus 2I. Now we need to separate real and imaginary parts. So 2x plus 1 plus I into 1 minus x by 2 plus I plus y plus 1, and if we take I common, minus 2y minus 1 by 1 plus 2I is equal to 1 minus 2I. Now we need to rationalize them. Now I will rationalize the two terms on the left hand side. So you will get 2x plus 1 plus I into 1 minus x. This we are multiplying and dividing by 2 minus I. So denominator will become 2 plus I into 2 minus I. It will become 4 minus I square. Now second term, y plus 1 plus I into minus 2y minus 1. This you multiply with 1 minus 2i, and denominator already you have 1 plus 2i. 1 plus 2i into 1 minus 2i will become 1 minus 4i square. That is equal to 1 minus 2i. So you get, now we multiply this into this, this into this, this into this, this into this. So we will get 2 into 2x plus 1 plus 1 minus x plus y plus 1 plus 2 into minus 2y minus 1. Here we are separating real and imaginary parts. This is real part plus I into imaginary part is minus 2x minus 1 plus 2 into 1 minus x minus 2 into y plus 1 plus minus 2y minus 1. That is equal to, we are cross multiplying. Now denominators will become 5 because 4 minus of minus 1, as I square is minus 1. So 4 minus of minus 1 will become 5. So that is 5 into 1 minus 2y. So if you solve this, you will get 3x minus 3y plus 2. Open the brackets and separate real and imaginary parts. Plus I into minus 4x minus 4y minus 2 equals to 5 minus 10i. So here, if we compare real and imaginary parts, 3x minus 3y plus 2 is equal to 5, and minus 4x minus 4y minus 2 is equal to minus 10. So we get 3x minus 3y is equal to 3, and minus 4x minus 4y is equal to minus 8. So if we take 3 common, we will get x minus y is equal to 1. And here if we take minus 4 common, you will get x plus y is equal to 2. If you solve these two equations, you get x and y values. So 2x is equal to 3. So x is equal to 3 by 2. And if you substitute x in any one of the equation, you get y as 1 by 2. Now after finding x and y values, we need to substitute in the given expression. So 2x plus 4y, that is 2 into 3 by 2 plus 4 into 1 by 2. 2 to cancel, 2 ones are 2 twos are, that is 3 plus 2, which is equal to 5. Option A. Now take the next question. If z is equal to 1 minus root 3i, then we need to find this expression. Z cube minus 3z square plus 3z. So directly I am starting the problem. So we need to substitute here 1 minus root 3i whole cube minus 3 into 1 minus root 3i whole square plus 3 into 1 minus root 3i. Now we know that a minus b whole cube formula is a cube minus b cube minus 3a square b plus 3ab square. And also we know a minus b whole square is a square plus b square minus 2ab. Now we need to substitute, apply these formulae in the first two brackets. So that is equal to a minus b whole cube. So 1 cube is 1 minus root 3i whole cube is 3 root 3i cube minus 3 into a square is 1 and b is root 3i plus 3 into a is 1, b square is 3i square. This is the expansion of first bracket. Minus 3 into, now a minus b whole square. A square plus b square minus 2ab. Then the third bracket, we just have to multiply 3 inside. So 3 minus 3 root 3i. So that is 1 minus 3 root 3. I cube can be written as I square into I. And I square is minus 1. So this will become plus 3 root 3i. Minus 3 root 3i. Plus 9i square will become minus 9. Now minus 3 into 1 minus 3 minus 2 root 3i plus 3 minus 3 root 3i. So 3 root 3i minus 3 root 3i get cancelled. So that is 1 plus 3 is 4. 4 minus 9 is minus 5. Minus 3 plus 9 plus 6 root 3i minus 3 root 3i. So 9 minus 8 is 1 and 1 plus 3 root 3i. So it's option B. Now take the next question. The product of all the values of root 3 minus I whole power 2 by 5 is. So let us say root 3 minus I whole power 2 by 5 equals to some x. So if I shift by 5 to the other side, it will become into 5. Now we open the brackets here. X power 5 is equal to 3 plus I square minus 2 root 3 I. So x power 5 equals 3 minus 1 minus 2 root 3 I. So x power 5 equals 2 minus 2 root 3 I. If we take 2 common, we get 1 minus root 3 I. So clearly, a product of all the values is 2 into 1 minus root 3I. That is option C. So take the next question. The number of common roots among the 12th and 30th roots of unity is. So first let me give you what is 12th roots of unity. So 12th roots of unity is 1 e power I into pi by 6, e power I into 2 pi by 6, e power I into 3 pi by 6, like that, so on up to e power I into 11 pi by 6. These are 12th roots of unity. And 30th roots of unity is 1 e power I into pi by 15. See, if you have 12 here, you should half it and write. So 12th root of unity means you get pi by 6. Same with 30th roots of unity, you get pi by 15. Because we do half of this 30. And e power I into 2 pi by 15. Then e power I into 3 pi by 15. Like that it continues until e power I into 29 pi by 15. So altogether you will get 30 terms here, and in the first one altogether you get 12 terms. So from these, what are common? So clearly, what are the common roots? Common roots are, like, see, if you take e power I into 3 pi by 15, 3 ones are 3 fives are, right? We can cancel the terms. So like that, if you take terms common, 1 is common, e power I pi by 3 is common, e power I 2 pi by 3 is common, then e power I pi is common, and e power I into 4 pi by 3 is common, and e power I into 5 pi by 3 is common. So if you write all the terms and do the cancellation, and if you take the common roots, you get these are the common roots. So altogether, the number of common roots is 6. That is option D.